let me introduce myself a little bit more. As Anna said already, I'm a GDE of Angular and Web Technologies and also a Women Tech Makers Ambassador. I'm based in Germany right now, and I'm living in a city called Leipzig, if you heard of that. So I'm traveling all over the world, talking about my most favorite framework, Angular, and bringing a lot of technologies to women and running a couple of free workshops. But I'm also working as a trainer and consultant for Angular. So whenever you like to ping me with any kind of question, feel free to ask whenever. My DMs are definitely always open. That said, I'm also a core team member of the NG Girls. If you haven't heard of that, you should. No, it's just we having like for 4 or 5 years already. We are 4 years. We are bringing the Angular framework to women who wants to get into web development, get into Angular specifically. I guess we organized our biggest workshop. I wasn't unfortunately part of it. Was in Medellin, Colombia. It was about 120 women, a full day, completely free of charge workshop, and 120 women eager to learn Angular with us. And this is really amazing. Apart from that, and because I have too much free time, it seems, I'm organizing 2 conferences, the Angular German conference called NGDE, and I'm supporting organizing the NG Rome conference, which hopefully will take place this year in October again as well. Enough for me. Let's first dig into what actually a compiler does and why do we need a compiler? Because maybe you think, yes, a compiler is something that compiles C, C++ code to machine code, right? So we don't really compile JavaScript, right? So when we talk about compiler or renderer or an engine, we mostly mean something like that compiles, transpile our Angular code, our TypeScript code to JavaScript code by using the ngC, the Angular compiler, which looks like this. So we have on the left side our Angular code and on the right side our JavaScript code. And this is exactly what was needed to be improved, right? So this JavaScript code will be generated regarding the ECMAScript version. Of course, we are targeting in our tsconfig JSON. There we write down we want to have ECMAScript 2015, or maybe we need to support ECMAScript 5 because we still have customers supporting the Internet Explorer. So this is where we jump in, and this is exactly what we need, what was needed to be improved. Apart from that, of course, the compiler takes also care regarding the whole scoping, that when we define all the ng modules and all the that it stays in this kind of scope. Also the evaluating of the property chains. Finally, we have the optional property, optional chain in TypeScript 3.7. And of course, the whole evaluating of type checking and variable in the function calls. So I promised you we have a rise of a new compiler. So let's see what kind of benefits we actually get from the new compiler. First of all, smaller. Smaller is always better, right? Also a faster compilation, and that it's easier to actually debug our application. And if it's easier to debug, we can even develop faster as well, right? So let me share some metrics with you that Stephen Fluen actually shared in one of his blog posts as well. I mentioned here below that we even have with Angular Ivy shipped in version 9, we have up to 40% of size improvement in large apps, up to 30% of small apps. We see that it's not that much in medium-sized apps, and we will even figure out later why actually. But in large applications, up to 40%, it's like almost half. It's really, really amazing. So I was like, okay, let's compile it. I mean, of course, I can read statistics on the web page, on the blog. It's amazing, but I want to compile it on my own and I want to see what kind of size I actually get. So what I did, I created a whole new web application and I compiled it once with ViewEngine enabled and once with Ivy enabled. And this is what I got. So the version I used here was Angular 9.1.2 and I compiled it. And with the ViewEngine, I got 1.3 megabyte and with Ivy, I got 14 kilobyte. I mean, this is already like, okay, blows my mind. It's really amazing. And I was like, how that? What is going on there? So I thought, yeah, let's just take a look into that. Let's just do it. So we see here the project. I haven't changed anything. I just created a new Ivy app. So I just removed a little bit of the boilerplate code here in the app.component.html file just to have it like a hello world example. As we see, I have the version 9.1.2, and in order to compile this with ViewEngine, I need to disable Ivy actually. So I need to go to the tsconfig JSON where we have our target version and everything. And down here we have this Angular compiler options. And here I have to set this enable Ivy flag to false. So now we have Angular version 9 with ViewEngine. So let's compile it, running ngc. And this is always the moment where I think of telling a joke, but we Germans have a rumor that we don't have a sense, sense of humor, so I never do that. And it's better like that. But the compilation was already really fast. So here we have this folder. So let's see what was created, right? So let's go into it, source folder. And here inside this app folder, we will actually see our JavaScript that was created from the app component. What would be really interesting for me, if you can write down in the chat, if you actually enabled Ivy already in your project, plus if you have ever actually compiled and took a look into this whole source code I'm doing right now. So let's open it and let's see what was actually compiled, right? A lot, right? Like a lot. This we have an app component.js file and metadata.json, ngFactory, and ngSummary. And now it comes to stylings and the test files. So we have 4 files that were compiled regarding our component. Okay, let's see the first file. It's the app component.js. Okay, this more or less looks like the JavaScript equivalent of our TypeScript component file, like the controller code. But what I actually want to show you, which is quite interesting, is the ngFactory JavaScript file. So if we take a look into here, and let me shortly split my screen, then it's a little bit easier to see. We see that inside this component ngFactory file, that here is actually the whole definition of our template code, right? So here's something like a function that is from the core framework, and here we create some elements, like on index 0 we set a div tag, and so on and so forth. And here we set on the index 1 we set a text definition node with a text hello. This looks so confusing. I mean, at least it did to me, right? I mean, in the beginning, I definitely needed the documentation to figure out what the hell is actually going on here. Okay, so far so good. What is inside the .json files? It's more or less just references between all these files and information regarding the whole dependencies of the component. So we have 4 files, right? So let's do it the Ivy way. So I will delete this folder and let's enable Ivy again by removing this flag, right? And let's run the compiler again. And hopefully I'm not forced to tell a joke this time, but it's really fast. cool. I'm really glad. So let's see what is compiled with Ivy, right? So opening the source folder and opening the app folder, we see one file. It's one file. We had 4 files before, right? We have one file. So let's shortly take a look what's inside here, right? So let me split my screen again. So we see a completely whole different thing. And first of all, it looks a little bit cleaner, of course, but let's see what's going on here. First of all, Ivy introduced something that is called static properties. We see it here, for example, this theta CMP, and CMP stands for component, of course. So each and every class has a static property now. And inside the static property, it's stored the whole definition of the component. Like this A0 is the core framework that is imported here. So we call a couple of functions from this core framework now to actually define our component. And even more, we have here as well inside the same JavaScript folder the whole creation of the template. Like we have here at our rendering phase 1, like RF means like rendering phase, and rendering phase 1 means the initial, and like Ention init, the initial going through the component, the init of the component, and the second means of course update. Like in the first rendering phase, the initialization of our component, now I have it, we call the element start, like on index 0, we create a div element. So it's this over here. Then we create a text node and we call directly the function of the frameworks, right? Here, this is really important, keep that in mind. Right now here, we really call directly all the functions from the framework. And then we call the function that we close the div tag as well, closing this element like it is now HTML template code. At the second rendering phase, we actually make this whole interpolation of this text, which is stored inside this context object that we will be given here inside as well. For me, when I read this, it looks much, much clearer. Don't get too much confused regarding this theta sign. There are rumors that they use this theta sign because it looks more like a stop sign. So you should never, ever touch this, and to be really sure they even pasted 2 theta signs in there that you really should not touch it. But there's no need to touch them actually, because this whole code will be rendered in the end, right? So there is actually another API, and I guess Manfred will tell more about this, that just has one theta sign. And this API, private API, will maybe be eventually public, out there for public use in the future. Okay, so we saw in the end, to sum it up, that with the ViewEngine, we have 4 files created out of our component, like the .js file, the factory, and the 2 JSON files. And with the Ivy engine, we just have 1 single file. This already seems like, oh, cool. This is maybe the reason why we have such a small bundle size, right? But it's not the only reason, right? Just because we have 1 file. So I digged a little bit deeper why actually with Ivy the bundle size is so much smaller, and then I figured out the ViewEngine is not tree-shakable. So what does it actually mean that something is tree-shakable? It means that every code snippet that is in use should be not compiled in the bundle, right? Like if we have, for example, a function to create a pipe, but we are not using this pipe function at all in our template creation, it should not be shipped in the end bundle. So, but the ViewEngine is not tree-shakable. That said, everything, even though we are not needing it, will be inside the end bundle. But why is it so? To know this, we have to dig again how actually the whole compile is compiling the whole template. And with the ViewEngine, we see it actually creates a so-called view definition with an array of instructions. So we have an instruction for creating an element, and we have instruction for this text definition. Okay, but so far so good. We already saw that somehow, but this is really simplified, of course. But what is the framework doing with this array of instruction? It's actually passing it through a whole switch case block. So for each and every template, like component, it passes this array of instruction here, and for every entry in this view definition, it will be matched against some cases. So for example, in our case, it will go to the first one, since we want to create an element, and then to the second one, since there was a definition of creating a text. But just at this place, we will call finally the functions of creating an element and creating a text. Before that, we just have an array of instructions, right? That said, we can't figure out during compile time which functions are actually being used in the end, right? So for example, as I mentioned it a little bit before, if we don't have the pipe inside our area of instruction, this create pipe instant function will still be shipped and compiled inside our bundle, since how can the ViewEngine know at that moment during compile time that we are going to use it, right? So it keeps everything inside the end bundle. And this is the main reason why a really small app has a lot of benefit compiled by Ivy. But if we going more like medium-sized app, where we actually eventually going to use all these template creation functions, it might not have that much benefits from it, right? Since we actually are using this function, so even Ivy can't tree-shake out that much. So the main reason why Ivy is able to tree-shake out everything, as I mentioned, you have to keep this in your head. Ivy enables that we during the whole template creation code, we call the functions directly. As we see here, we are inside our component, and the component is calling the function directly. And of course, when the template calls the functions directly, we have a reference to it, and we know exactly which functions are eventually going to be called, and we can tree-shake them. We can tree-shake out all the functions that are not being called. And as I said, this is the main reason. Great. So now we figured out why the bundles are so much smaller. Let's shortly go over why we have a faster compilation. And as Kara said in her keynote at the NGConf this year, even up to 40% faster compilation improvements. Of course, first of all, we just compile one single file. Okay, this seems too easy to be true, but yes, of course, if you just compile one single file and not just 4 files with references to each other, of course, it's a little bit faster. But the main reason is actually called something like locality principle, or in other words, a separation of separate compilation of dependencies. The component has all information for being compiled. Okay, what does it mean? Let's take a look how the ViewEngine is actually handling all the dependencies and its dependencies. Like if we want to use an ngIf over here, for example, we see that, okay, we want to have an ngIf, but we also see something in this array, right? Like a view container ref and a template ref. But these two services aren't dependency of the component. They are actually dependencies of the ngIf, right? So that said, whenever the dependencies of the ngIf changes, we have to recompile this whole component as well, right? So why shouldn't we just maybe separate this dependencies, like having a separated compilation of these dependencies, and that's it? Yes, and this is exactly what's going to happen with Ivy. With Ivy, it looks more like that. We just say, okay, I want to have an ngIf. I want in the update rendering phase, we want to set a property ngIf, and I demand as a directive the ngIf. And then there is inside the framework a class that has the static property ng directive definition, and it has all it has all the knowledge and everything that it needs to know to define this directive, like all the dependencies, right? So whenever there is actually a dependency changing for the ngIf, just this code snippet will be needed to compile. And this is pretty amazing. It seems so simple, but now everything is so clean and separated, and this is one of the main reasons why they increased the build so much. It's really, really amazing. It's also way easier to debug right now. Since we have, of course, a cleaner API, it's pretty much really easier to read, to set breakpoints, and to really read the code that is generated by Ivy really way more easier. We also have improvement of the stack trace, which looks like this. Like here we see before with the ViewEngine, we can get much out of the stack trace actually. Like we see our most favorite ever message, expression change after it has been checked ever. And always when I'm reading this word, I think actually that just Germans have this rumor that we're just putting a lot of subjects behind each other and it creates a whole new word. And it always feels like that when I read this error actually. But after Ivy is enabled, we get a much clearer stack trace. So you can see we actually have exactly the function app component template where this issue is actually raised, and we can really go step by step through it. And this helps already a lot. As well, each and every error that is printed on the console in the browser will now be also printed on the console where we want ng serve. And everything that is printed out there as well can be involved in our build process, like whatever kind of CI/CD pipeline we have, Jenkins, Travis, Azure, GitLab, everything that is printed out there can be maybe sent in an email to someone, or we can handle it accordingly. So this is another great improvement. And last but not least, one of the biggest awesome things in my opinion for debugging is the ng object. With this ng object, we can get inside the console, the developer console, for example, we can get the component, and then we have the component object in stored over there. And then we can maybe assign a new value. We can call function on this, the function that the component has, of course. We can change the value, and this value will not be reflected in the first place in the UI till the time we will call apply changes, because apply changes will of course run the whole change detection cycle. So we can completely simulate all the steps the component eventually going to do with this ng object. And this helps a lot of actually getting through the whole code as well and debugging it. Another great thing I like to mention here is that the Angular team was not like, okay, we just create a new compiler and we don't care about the old projects. Because I know yesterday I had another talk and I asked, okay, so which kind of Angular versions you are using? And they were like, actually less than 30% actually using Angular 8 and higher and newer. So I was really astonished by that. So, but of course, the Angular team took care of that as well. So backwards compatibility was a huge point over here. So what they actually created are two separated compilers. Like one compiler that's called the Ivy compiler, the normal compiler that just compiles Ivy compatible code to the bundle. And of course, something else that is called the Angular compatibility compiler. It actually goes through your whole node modules and checks if it's Ivy ready, like if it's possible to compile it with the Ivy compiler, and if not, it converts actually the whole old style modules into something that's called TypeScript definition file. And with this definition file, it is actually possible for the Ivy compiler to compile it inside the bundle. And they're still really working on it and doing a great job over here. And I would like to really empower you and encourage you to enable the analytics that you will be asked when you run the Angular CLI. You will be asked, is it okay for you that you share your statistic to the Angular team? And I really want to encourage you to do that because it helps the Angular team so much to get the data of the real-time projects. Because these are the projects out there. You are the customers of the Angular team, and we need your data, not to do something bad about it. We just need it to make Angular even better, and especially Ivy. That said, let me summarize a little bit what we have learned today from my talk. I will reduce the bundle size really significantly. Like really a lot, especially when it comes to small and large apps. It also only recompiles what changed, since it has this separated compilation of dependencies pattern now enabled. It also is so much easier to debug. Plus, it has still this great backwards compatibility with the new NGCC compiler. There's also something I like to mention here, because I always get a lot of feedback like, okay, I compiled with Ivy and I'm really frustrated because the Angular team did so much effort in Ivy and my app doesn't, the bundle size is not, didn't really change. Yes, of course, this could be the case, but you have to think more regarding Ivy. Ivy enables so much now. And that's why it's so awesome that Manfred is the talk afterwards, because he will exactly talk about all the great APIs, all the great things you can now develop with Ivy. And Ivy is not just small bundle sizes. Ivy is an enabler for creating so many awesome, great new apps, making NG modules optional, maybe even removing Zone.js and improving the performance, the runtime performance a lot with your application. So think about that as well. And not only Ivy will just reduce the bundle size, which is quite popular in the whole Twitter timeline, and everyone is just speaking about that, but it also enables a new way of developing of Angular applications. That said, thank you so much for me to being allowed to speak here, to share my knowledge about Ivy. We have a shortly Q&A session right now, but if you weren't able to ask your question, you can ping me anytime. As I said, my DMs are always open. Find me on my website, on other contacts, ping me on Twitter, send me an email. Whenever, I'm always free to help people, and I love talking a lot, so I love to share even more regarding Ivy. And now I'm really looking forward for the next talk of Manfred, telling even greater things you can do with Ivy. So thank you so much.